Hello, this is Mrs. Brookshire. This section 5.2 is on probability rules. So we're going to be talking about a lot of different problems that involve rolling die, spinning a spinner, selecting a card from a deck of cards. So the first thing I want to do is go over the definition of a probability model because this is what we have up here. That's an example of one. So let's talk about what that is. A probability model is a description of some random process that consists of two parts, a list of all possible outcomes and the probability for each outcome. The list of all possible outcomes is called the sample space. So if we look up here, what you see is this is a sample space for the sum of two die. So there's 36 possible outcomes. So the first thing to have a probability model is you need to list the sample space, what are all the outcomes? And then the second thing is you need to give the probability for each outcome, which we see right there. All outcomes are equally likely with a probability of 1 out of 36. So make sure you realize that rolling a 6 then a 1 is different than rolling a 1 then a 6. Okay? So there are 36 total possible outcomes, and the probability of rolling any of these particular events, like getting a 1 and a 1, would be a 1 out of 36. So the other definition we're going to discuss is what is an event. An event is any collection of outcomes from some chance process. So an event would be like, what's the probability of rolling a sum of 2? So the probability of that would be, there's only one way, so it'd be 1 out of 36. All right, so let's go down and do an example that using this probability model. It says find the probability of event A, where A is the number of outcomes with the sum of 5 when rolling 2 dice. Okay, so what you might want to do first is write down, where am I going to get a sum of 5? And one thing a lot of times I'll do is I'll come up here and I will circle all the places that you could get a sum of 5. Okay. So where could I get a sum of 5? Well, I could roll the first dice and then the second dice, and I get a 4 and a 1, and then I could get a 3 and a 2, and then I could get a 2 and a 3, and then lastly I could get a 1 and a 4. So there's 1, 2, 3, 4. So the probability of A is going to be 4 out of 36. So when you write your probability, you always have the number of outcomes with a sum of 5. Number goes on top. Number of possible outcomes for the event. So this would be to get a sum of 5 over the total number of outcomes. Total number of outcomes when rolling 2 die. Okay, so the top is how many ways could I get a sum of 5? There's 4 ways. And then the bottom is the total number of outcomes. So that'd be 1/9. A lot of times they'll reduce that or possibly even write it as a fraction. So don't forget, well, we're going to talk about some probability rules in just a second. All right, so the next example, or on the next page. A spinner has 3 equal sections. You've got red, blue, and yellow. Suppose you spin the spinner 2 times. Give a probability model for this sample process. So we've got, we want to write out all the different possibilities that we could get if we spin the spinner 2 times. So this is going to be our sample space. Okay, and our sample space, let's start with red. So let's say we spin red, and then the second spin's a red. Then we spin red, and the second spin is a blue. Then we spin red, and the second spin is yellow. All right, now let's go down and do blue, then red, blue, then blue, blue, then yellow. Let's do yellow and red, yellow and blue, yellow and yellow. So this is my sample space. This is all the possibilities that I could get when I spin 2 times, okay? So the other part of a probability model, the first part was write out a sample space, and the second part was to actually give the probability. Because the spinner has equal sections, each of these probabilities are likely with a probability of 1/9. Are likely with a probability of 1/9. Okay, so when you are writing out a probability model, you need to have both aspects here. You've got to have the sample space, and you also need to list, tell what the probability would be for each outcome. Okay, so part B. Define event A as spinning blue at least once. The probability of A, which would be spinning blue at least once. So let's see what we have here. Here's spinning a blue, a blue, a blue twice, a blue, and a blue. So the probability, we look at there's 5 outcomes, so it would be 5 out of 9. And again, they could possibly change that to a decimal. Either answer would be acceptable. So on the top, we have how many ways could you get a blue at least once, and on in the denominator, your total number of ways. Okay? So the next thing we're going to do is we are going to write down some definitions and some basic probability rules as well. So I'm going to give you just a minute to jot these down, and then we'll go through each one. So I'm going to stop this video for just a minute and let you have a moment to copy this down, and then we'll talk about each one. Okay, so let's go over these terms, these rules. All right, number 1, if all outcomes in the sample space are equally likely, the probability that event A occurs is, and we talked about this on the previous example, to find the probability of an event, you find the number of outcomes for the event, like how many times could this happen, and then the denominator is always the total number of outcomes in the sample space. So that's how you find the probability of an event. Number 2, the probability of any event is a number between 0 and 1. 0 would be it would not happen. 1 would be it would absolutely happen. So the probability that an event happens would be between 0 and 1. Number 3, all possible outcomes together must have probabilities that add up to 1. So if you have all the probabilities listed, you need to check to see that they do add up to equal 1. The probability that an event does not occur is 1 minus the probability that an event does occur. So if they ask you what's the probability that this won't occur, find the probability that it does occur, if that's an easy way to do it, and then 1 minus it, okay? So there's a rule, it's called the complement rule, all right? And so to find the complement of A, which means A is not happening. So this means A doesn't happen or is not happening, okay? So to find the probability that A doesn't happen, you would do 1 minus the probability that A does happen. So A raised to the C power is called the complement of event A, which means A is not happening. Okay, one more definition and a couple of rules with it. 2 events, A and B, are mutually exclusive. So I know you've probably heard that word before, that term, mutually exclusive. It means that one has nothing to do with the other, okay? Another word you might hear is disjoint. Both of those mean the same thing, mutually exclusive and disjoint. If they have no outcomes in common and so can never occur together, that's what mutually exclusive means. There's no common outcomes. They can't happen at the same time. An example would be if I asked a student at Glenver, said, hey, what year are you? There's no way they could be both a senior and a sophomore, for example. So those 2 events would be mutually exclusive. The notation, if I ask you, hey, what's the probability of A and B happening? you would say 0 if they're mutually exclusive. So what's the probability you're a senior and a sophomore? 0, okay? The probability that they both occur at the same time. Now, if I said to you, hey, what's the probability that A or B occurs? So this is addition rule for mutually exclusive. If two events are mutually exclusive, they cannot happen at the same time. And I say to you, hey, what's the probability of one or the other happening? You would do the probability of A plus the probability of B. Okay, so hopefully we're going to be working through some examples using these rules. So let's look at the first problem here. It says, suppose you tear open the corner of a bag of M&M milk chocolate candies. You pour your candy into your hand and observe the color. According to Mars Incorporated, the maker of M&Ms, the probability model for a bag from the Cleveland factory is this. So here are all your different colors that you could get, and here are their probabilities. Part A says, explain why this is a valid probability model. Remember, there's two things that you need to check. Number one is each probability between 0 and 1. Yes. And number two, do all these probabilities add up to be 1? So that's how you know if you have a valid probability model. So let's jot down what I just said. The probability of each outcome is between 0 and 1. And the second part you need to look at is that the sum adds up to be 1. And if you add those probabilities up, they will add up to be 1. Okay, the next part, part B, find the probability that you don't get a blue M&M. So what you could say is you want the probability of not blue. And another way you could say that would be the probability of blue complement. Not blue is the same as the probability of blue complement. So what we set up here is an easy way to do it would be 1 minus the probability of blue. Okay, 1 minus the probability of blue would be your probability that it's not blue. So if you look up here, blue is 0.207, so it would be 1 minus 0.207, and that is equal to 0.793. So the probability of not blue, okay, would be 1 minus the probability that it is blue. Another way you could do it, some people go, well, can't you just go add all those up? Yeah, you could just go add up all of these other colors and it would give you the same answer. So it's kind of just a quicker way to get your answer here. Okay, part C. What's the probability that you get an orange or a brown? Okay, so the probability of orange or a brown. Okay, so the first thing you want to think about is, are these mutually exclusive? And your answer is yes, they are. There's no way I'm going to pick an M&M and it's both orange and brown. So they are mutually exclusive. So our rule says to find the probability of orange or brown up here, you just find the probability of orange and you're going to add that to the probability of brown. Okay, so the probability of orange when you look up here is 0.205 plus the probability of brown is 0.124. So when you add those two together, you end up with 0.329. Okay, so probability, oops, let me move that up, is, you just got to think about, things a lot of times. Are they mutually exclusive? That is one thing you want to consider when you're finding the probability. Okay, so that's one example. All right, the second example, it says, suppose we choose an American adult at random. Here are the two events. A, the person has a cholesterol level of 240 milligrams per deciliter of blood or above. So A is basically the person has a cholesterol level of 240 or above. B, the person has a cholesterol level of 200 to less than 240. Okay, so this would be high cholesterol. This would be borderline high cholesterol. According to the American Heart Association, the probability of A is 0.16 and the probability of B is 0.29. 1, explain why events A and B are mutually exclusive. So why do you think that events A and B are mutually exclusive, which means they can't happen at the same time? Okay, well, if you think about it, can a person that I choose have a cholesterol of 240 or above? At the same time, they have a cholesterol of 200 to less than 240. And your answer should be no, that cannot happen at the same time. So that is why they are mutually exclusive. So I kind of jotted this down, why they're mutually exclusive. So events A and B are mutually exclusive because a person cannot have a cholesterol level of both 240 plus and between and less than 240. So that's why A and B are mutually exclusive. You can't have a person, you cannot have a person cannot have a cholesterol level of both 240 or above and between 200 and less than 240. Okay, can't have that happen. Okay, number 2, say in plain language what the event or A or B is, then find that probability. Okay, so we talked about how they are mutually exclusive. So if I asked you to say in plain language what this meant, you would say, okay, what is the probability that a person has a cholesterol level of 240 or above, or the person has a cholesterol level of 200 to less than 240? So that's how you would say that in words. I kind of jotted that down, so I'm going to let you copy that. The event of A or B is a person who has either cholesterol level of 240 or above, or cholesterol level between 200 and less than 240. So that is how you would say that in words. Okay, and then the second part says to find the probability of A or B. Since these two events are mutually exclusive, to find the probability of A or B, we're going to find the probability of A, and we're going to add that to the probability of B. So those probabilities are given up here. So the probability of A is 0.16, plus the probability of B is 0.29. So that would be equal to 0.45. All right, part C. Let C be the event that the person chosen has a cholesterol level below 200. Find the probability of C. Okay, so below 200, if we think about it here, A is they have a cholesterol level above 240 or above. And then event B was 200 to 240. So below 200 would be basically 1 minus the probability of A or B, if you think about it. Okay, because it would be neither of these, but below 200. So what we're going to do then is we're going to take that number that we found here in part B, and 1 minus 0.45 would equal 0.55. So that's the probability that a person chosen has a cholesterol level below 200. All right, so there is some problems using our basic probability rules. We're going to continue on with this. We have some more. What kind of vehicle? Randomly select a new vehicle sold in the U.S. in a certain month. The probability model for the type of vehicle is chosen is given here. So you've got passenger car, pickup, SUV, crossover, minivan. What is the probability that the vehicle is a crossover? If you look at your probabilities, you notice that they don't give you that. So the way we're going to find that probability that it's a crossover is the probability of a crossover equals, and you guys have probably figured it out, you're going to do 1 minus, and then you're going to do, because you know all the probabilities are supposed to add up to be 1. So what we're going to do is we're going to add up all those other probabilities, and then we're going to subtract 1 minus them. So that's the reason that because it does says, how do you know this? So that these will add up to be 0.76, and when you subtract 1 minus 0.76, you get 0.24. How do you know? The sum of the probabilities must equal 1. The sum of the probabilities must equal 1. Okay, so that's the reason. Find the probability that the vehicle is not an SUV or a minivan. So to find that probability, excuse me, we could do 1 minus the probability of SUV or minivan. Okay, so if we find the probability of SUV or minivan, then we can 1 minus, so SUV is 0.10, minivan is 0.05, so 1 minus 0.15 is going to be equal to 0.85. All right, the last one. Given, that's an important word in probability, that the vehicle is not a passenger car, okay, what is the probability that it is a pickup truck? Okay, so this, we're going to talk a little bit more about conditional probability later on. So if it's not a passenger car, so we want to know, basically what this is going to be a fraction, okay? The probability that it's a pickup truck goes on top, which would be 0.15, and the probability that it's not a passenger car, so passenger car is 0.46, so it'd be 1 minus 0.46. So this is what we call a conditional probability. So this would be 0.54, and then you would divide those two, and that's going to give you the probability. And we're going to talk a lot more about conditional probability, but I was kind of just, since we're on this problem, would show you how that works. So when you divide 0.15 divided by 0.54, you get 0.27777 or 5/18. So we'll just say 0.278. And that is called a conditional probability, and we'll talk more about that later in the chapter. All right, we're going to talk about the last thing. Sometimes with probability, you will have a two-way table, okay? And so we're going to go through and work a couple of problems that deal with probability in two-way tables. Students in a college stat class want to find out how common it is for young adults to have their ears pierced. They recorded data on two variables, gender and whether or not they had their ear pierced. For all 178 people in the class, the two-way table summarizes the data. Suppose we choose a student from the class at random. Define event A as a male student and event B as getting a student with a pierced ear. So the probability of B would be the probability that they have their ear pierced. So when we look at this two-way table, what numbers would you use? You would use yes ear pierced, which is 103, divided by the total, which is 178. And lots of times they will change that to a decimal. So the probability is 0.579. Find the probability of A and B. Interpret this value in context. So what do you think the probability of A and B means? It means, probably A and B. It means that you are both male and have your ear pierced, okay? So when we go and find that, where is male with ear pierced? That would be 19 out of 178. 19 out of 178. So and means you want both things happening, male and ear pierced. So that's equal to 0.107. And then if we have to interpret what this value means, you'll say something like there is about a 1.1% chance that a student selected from this class, is a male and has as his ears pierced. From this class is male and has his ear pierced. Okay. Part C, find A or B. So we want the probability of A or B. Okay, first question. Are these two events mutually exclusive? And your answer would be no, because we see that we can have a male with their ear pierced. Okay, so there's going to be a rule that we're going to talk about here in just a second about how do you find A or B. You know, if they're mutually exclusive, you would just find the probability of A, the probability of B, and add them together. These are not mutually exclusive. So one way we could go about this is we could say, okay, male. What's the probability that they are male? So that would be 19 out of 178 and 71 out of 178. So these are both like the male columns. So 19 and then the 71. Plus, and then the other part is or pierced ear. So or pierced ear, you'd want yes. So you'd want this too. Well, you've already calculated that. So don't put that back in there, but you could put the 84. So when you add that up, you end up getting 174 out of 178, which is equal to 0.978, okay? So that's one way to do this. It's just to go through and count how many ways do you have male. Well, you'd have 19 out of 178, and then you have to add that too, or you could add those together, which would be 90 out of 178. And then you'd have to add, you've already had this, so you can't add that twice. But you would go and add the 84 out of 178 for a yes. Okay, so that would be my answer. All right, so let me show you there's another way to do it. If A and B are any two events resulting from some random process, the general addition rule says this. To find the probability of A or B, it's equal to, this looks familiar, probability of A plus the probability of B, but you have to subtract out that overlap, A and B. Okay? So if you wanted to do it, you could do this problem, this rule, and I'm going to just show it to you really quickly. So the probability, and you're going to see we get the same answer, of A or B. Really, you can use this for mutually exclusive as well, but the issue is if they're mutually exclusive, that's equal to 0. So that's why on mutually exclusive, you just add the probability of A and the probability of B because they can occur at the same time, so that's 0. So the probability of A is, let's see, A was male. So that would be 90 out of 178 plus the probability that the ear is pierced, 103 out of 178. And then you have to subtract out that overlap because you can't count that. Like if you look at this, you've counted at 19 here and you've counted 19 here. So you actually have to subtract out that overlap. And if you go through and you do this right here, you end up with the exact same answer, okay? 174 out of 178, which is 0.978. So this to me is a whole lot easier if you need to kind of, that rule is probably A or B, okay? So if it's mutually exclusive, what happens is this is 0. So that's why it's probability of A plus probability of B. But if there is overlap, you do have to subtract it out, and I've kind of showed you why that is. All right, I think we have a couple more examples, and then we will be done. So the next problem says, a survey of all students in a large apartment complex reveals that 68% use Facebook, 28% use Instagram, and 25% do both. Suppose we select a resident random. What's the probability that the person uses Facebook or uses Instagram? So what I was going to do, we're going to use our probability of Facebook or Instagram. Okay, so if we use that rule we just learned, the probability of Facebook plus the probability of Instagram, then you have to subtract out the probability of Facebook and Instagram. That's kind of like your overlap part, like we saw in the two-way table. So the probability of Facebook is 0.28. The probability of Instagram is 0.25. And the probability that they do both, whoopsie, I messed up here. Sorry about that. Let's start over. The probability of Facebook is 0.68. The probability of Instagram is 0.28. And then we have to subtract out the overlap that they do both. So when you go through and you do the math here, you get 0.71. So that's a real easy formula to learn. How do you find the probability of one or the other? Okay, many probability problems involve simple computations that you can do on your calculator. This is an AP exam tip. It may be tempting to just write down your final answer without showing the supporting work. Don't do it. A naked answer, even if it's correct, will usually be penalized on a free response question. That's simple. You just need to show what am I doing and then get your answer. Don't just do the math and write the answer. Last question. Yellowstone National Park staff surveyed a random sample of 1,526 winter visitors to the park. They asked each person whether they belonged to the environmental club, like to an environmental club, like the Sierra Club. Respondents were also asked whether they owned, rented, or had ever used a snowmobile. The two-way table summarizes the events. Suppose we're doing one of the following surveys. Number one, what's the probability that the person in environmental club is an environmental club member? Okay, one thing I'm noticing here is there's no totals. So I'm going to go through and we're going to total this column, because we will use these, is 1221. We're going to total this column is 305. We're going to total the rows as well. So this is 657, 574, 275, and then 1526 is our total. Okay, so number one. What's the probability that the person in an environment is an environmental club member? So that would be, here's environmental club, this is snowmobile experience. So yes would be 305 out of 1526. Well, that is equal to 0.1999. Okay? Number two, find the probability that you're not a snowmobile renter. Not a snowmobile renter. So go to not a snowmobile renter. So here's your snowmobile experience. You've never used, you've rented, or you're an owner. So what you would want to add here is never used, probability of not a snowmobile renter. So there's a couple ways you could do this. Wow, I misspelled that. Not a snowmobile renter. Okay, so what you could do is here's the renters is right here. So it would be like 657 plus the owner, 275. Actually, this is supposed to be a 9, guys. Sorry about that. 295 over 1526. So that's equal to 952 over 1526, which is 0.6239. Another way you could do this is 1 minus the probability that you are a renter. So this would be another way. So you could do 1 minus the renters are 574 over 1526. And if you do that, you will also get the same answer here. Either way would work. Okay, that might be quicker. So not a snowmobile, 1 minus probably that you are. Okay, number 3. Find the what's the probability of the environmental club member and not a snowmobile renter? So environmental is a yes, and not a snowmobile renter. Not a snowmobile renter. So what you would want to do here is, here's the renter, so you'd want to add the 212 and the 16. 212 plus 16 is 228. So 228 over 1526. And that's equal to 0.4194. Okay, so we kind of just went through and it was a yes, okay, and not a snowmobile runner. So you could just add those two. And the last question, find the probability that the person is not an environmental club member or is a snowmobile renter. So the probability of not an environmental club member or snowmobile renter. I'm having some troubles with that. Snowmobile renter. Okay. So what you could do here, what's the probability that you're not an environmental club member? So that would be 445, 497, 279. I'm kind of just going through here and marking down. Here's your not. And then the last one is you are a snowmobile renter. So a snowmobile renter would be And you've already put the 497 in, so you just need to add the 77. So I kind of just went through and just picked out those numbers and added those together. And that's what I got here, 0.8506. The other thing you could do is we could use our rule here and do the probability of not this plus the probability of a snowmobile renter, and then you subtract out the probability of both, and you would get the same answer. And snowmobile renter. So not would be 1221 over 1526 plus snowmobile renter would be 574. Man, this might be easier to do it this way. Use the rule and subtract out both. So not and a renter would be minus the 497. So if we went through and we did it that way, let's check that and make sure we get the same answer. So you'd have 1221 and 574 minus the 497, which is going to give you, let's see, the same answer. So that's going to give us the exact same answer. That might be such an easier way to do it than just going through and picking those numbers out like that. So go through and actually use your rule. So if you see or, there's an overlap. So do the probability of an environmental club member plus the probability of a snowmobile renter, subtract out the overlap, and it gives you the same answer. So much easier. Do it that way. And that is all we have for this section. We have one more section that we're going to work on.